All right. Hello, everybody. We're looking at the second section of topic 8 right now. Our topic talking about transformations. In our previous lesson, we talked about translations. Okay. And that was where you took something that was a slide. All right. Let's see if we can get this picture fixed up. There we go. A slide is what we were looking at before. And that's just taking whatever image it was. It could be a point, it could be a whole entire polygon, whatever it is on your graph, on your XY plane, you took it and you moved it somewhere else. That was a translation. So today we're looking at reflections. We've got this picture of Mulan because it's the same thing on both sides of that sword in the middle of the picture, right? You've also got in that movie Mulan the classic Disney hit where she sings, "When will my reflection show who I am inside?" And it'll just get you right in the feelings every time, okay? So it's good stuff. We've got Mulan with our reflections, and we're talking about reflections. And that first blank that you fill in on your notes is that a reflection is a flip. It is a flip, and that FL is circled between flip and flexion right there so that you can keep track of which is which. All right? Just like a translation was a slide, a reflection is a flip. All right. And when we're reflecting over the x axis, it's pretty easy to visualize moving taking this red square and flipping it down over the x axis to get this green square. Okay. You take that and you flip it over. And what happens to your coordinates is this: all of your original coordinates, whatever your x and y were, those numbers stay the same, except the y coordinate gets the opposite positive or negative sign. Okay, so we say that you change the sign of y. When you're reflecting over the y-axis, it's the same thing. Okay, the y-axis, this vertical line right here. Well, if you flip over, you're taking this and you're flipping it around over that line to get this triangle. So your original A was at 2, 1. Your A prime is at negative 2, 1. What you did was you kept the y value, but you changed the sign on the x value. So you see we have a negative in front of the x right there. All right. So you change the positive negative sign of the x. Okay. Up next, we are looking at an example. Okay. We've got a triangle already on there. TUV has given coordinates. And when we talked about flipping over the y axis, reflecting over the y axis, we said that we keep the y value, but we change the sign of the x. So that 2, 3 of t is going to turn into negative 2, 3. Positive 8 and negative 5 turns into negative 8 and negative 5. Positive 2, negative 5 turns into negative 2, negative 5. And we can put all of those points onto our graph here pretty easily. Okay, and you can see how this becomes the flipped over version of the triangle. You can see pretty easily how it becomes the reflected version of this triangle. And right there we have it. The reflected version of that triangle reflected over the y-axis. That's what it would look like. Up next, we're looking at reflecting over the x-axis. So we're flipping it from here. We're kind of going up. We're flipping it over this line this time. Okay, so just like before, we wrote down that when you're reflecting over the x-axis, you keep the x, change the sign of the y. So instead of 2, 3, we're going to have 2, negative 3. Instead of 8, negative 5, we'll have 8, positive 5. Instead of 2, negative 5, we'll have 2, positive 5. And again, we can put all of those points on the graph pretty easily. You can put all those graphs on all those points on the graph pretty easily. But there is one thing that I want to point out here, and that is this: when you put these points on the graph and you draw your new triangle, you run into a bit of a problem, and that's this: our original triangle and our reflected triangle that we just made, they overlap each other. Okay, it can be really easy to mix stuff up. So, unlike with translations, you really need to go by what these rules are to change your coordinates and then draw the coordinates. Instead of just counting spaces, make sure you know what the rules are to change your coordinates. Okay, when you're doing a reflection, use the coordinate rules. Don't just count the spaces on the graph. Go on now to reflections over other lines. Okay, I think conceptually reflecting over an axis is pretty easy because you're taking this and you're just flipping it over that vertical line. You take this and you flip it over that horizontal line, and it's pretty easy to visualize that. What's harder to see, in my opinion, is reflecting over a different line. So this line right here, y equals x, has the following points on it. Okay, if you drew this line y, using your mx plus b, this is y equals 1x plus 0. So it's, whatever your x value is, your y value is the same when you're on that line. Well, that makes a straight diagonal line. It follows the path of the mouse that I'm given right here. Okay, it makes a straight diagonal line with a positive slope of 1 going up like that. So if you have one point or one shape that's below the line and you're trying to reflect it to up above the line, it does some weird stuff. Okay, what happens is your original x and y that you started with, when you reflect it over this line, the x and y trade places. Okay, the x and y trade places with each other. So when we look at this example that's on your paper, our original a is at negative 4, 2. Our a prime is at 2, negative 4. Our original b is at negative 3, negative 1. B prime is negative 1, negative 3. C is at negative 5, negative 2. C prime, negative 2, negative 5. Okay, all of the same x and y values, except they've traded places. Okay, this other line that we're reflecting over is y equals negative x. That's using your format mx plus b. That's negative 1x plus 0. And it's got some opposite things. Okay, so just like this line goes straight up with a positive slope, this one right here, y equals negative x, goes straight down with a negative slope. Okay, and when you're reflecting over that, some pretty weird stuff happens too. You trade the places of your x and y, and you make them the opposite, positive and negative. So looking at our original a was at 1, 2. Our reflected a prime is at negative 2, negative 1. So we traded the place of the 2 and the 1, and they were both negative. Okay, that's what happens when you reflect over that particular line. We're going to do some more examples with it right here. All right, we've got the same triangle TUV, all of the same points right here as our first example. And we're going to reflect them over these two lines. Okay, so first, if we're reflecting over the line y equals x, the rule right here says that your original x and y trade places in the reflection. So 2, 3, it becomes 3, 2. 8, negative 5 becomes negative 5, 8. 2, negative 5 becomes negative 5, 2. So let's draw that reflection on there. We got that one. We got this one up here. And we've got another one down here. So look at this triangle that we get from it. Okay, when you just look at first glance, it looks like those triangles are not even related to each other at all. But then when you look at the coordinates, they clearly are. Okay, the blue one is the reflection of the black original one. Go on over now to reflecting over the other line. Okay, this time we're going to be reflecting over. Y equals negative x. It's the other line that we were looking at. This time we reflect over the other one, and according to our rule that we wrote down, we swap the place of x and y, and we change both of the signs. So we trade place of x and y, and swap the signs. So 2, 3 becomes negative 3, negative 2. It's all of these same points, except you've changed all of the positive and negative signs. Okay? I'm going to trust that y'all can graph that and draw the triangle on your own. Okay? It is very difficult to tell, as you could see from that last one. It is very difficult to tell sometimes what the reflection is going to look like when you're done. So what you need to do is look at the coordinates, and that's what this whole chart right here is. This whole chart gives you a point to start with, and then it asks you if you do an x-axis reflection. Well, what we wrote down on the paper was that an x-axis reflection keeps the same x value, but it changes the sign of the y value. So instead of 3, 6, we've got 3, -6. When we reflect over the y-axis, we keep the y value and we change the sign of the x value. So instead of 3, 6, the reflected one would be -3, +6. Okay? When we flip over this line, y equals x, we trade places. X and y trade places. Instead of 3, 6, we have 6, 3. And our last one, y equals -x. When you reflect over that line, you trade places of both of them, and you trade the opposite positive and negative sign. So it's -6, -3. Okay? I'm going to look at one more example, and then I'm going to trust y'all can do the rest on your own. You can fill in the blanks and check your work. Okay? If we're flipping over the x-axis, x is the same, but y changes. So we got -2 still, but it turns into +6. If we have flipping over the y-axis, we keep the y value, but we change the x value, so +2, -6. If we are flipping over this one, we trade places. -2, -6 becomes -6, -2. If we're flipping over y equals -x, okay, look for that negative sign right here in the notation, and that's what'll do it. You will trade places and change signs. So +6, +2. Okay, this negative sign right here. When we wrote the rule, that doesn't necessarily mean your final answer should be negative. It just means that you have to change the positive negative sign in your final answer. Okay, that's all that means. I'm going to trust that y'all can get the rest of those on your own, and just fill those in on your own time and check your work on it. And that'll be the end of this lesson. Okay, there's some Canvas problems that go with it. It'll be good stuff. And don't forget what happens when you make 100 on your Canvas. All right, y'all have a good one. We'll get back at it another day to talk about rotations. Thank you.